All right, welcome back. So in the last video, we connected a photoresistor in this kind of setting and wrote code to read from it and convert that to a voltage value. Now, let's imagine that we had a sensor that instead of running at 5 volts, runs at a different voltage, like 3.3 volts. So in that case, now let's see what will happen. So I'm going to basically simulate a 3.3 volt sensor by changing the VDD, or let me do this again. So changing the input power, which is currently connected to 5 volts, I'm going to switch that over to, oh, I don't want to sort that. What I want to do is basically move this over to 3.3 volts. So now I have this particular sensor connected to a 3.3 volts. So if I actually bring in a multimeter, voltmeter, so multimeter, if I bring in a multimeter, and also let me put that multimeter right here, and what I want to measure is the voltage across that right there. So if I was measuring that, so now I see, look at this, this particular sensor is currently seeing dark values, so it should be 3.28 volts. And when I bring it down, I see it at 1.11 volts. So now range has changed from 3.3 to 1.1. So if I bring my voltage value back to 5 volts, let me stop the simulation. If I bring my voltage value back to 5 volts and run that exact same simulation, notice that when it's dark, it's at closer to 5 volts and 1.68 volts. So that's the difference between these two settings. So how does the Arduino interpret that change? So let's see. So I'm going to connect it to 3.3. Let's look at our Arduino code that we have. In this case, let's see what that will show up as with the same code that I had before, because it's still running at A0. It's giving me a value, converting that value from the reading to actual voltage. So if I start that simulation, what would I see? Well, if I leave everything alone, everything looks fine because my raw reading is now 671 and it's telling me that the voltage value is 3.28. That's what this serial monitor is telling me. I haven't changed anything in the code. The voltmeter is telling me that the voltage across uh, the photoresistor is also 3.28. So let's move this around and give it some brightness. I see 1.77 volt on the multimeter and 1.76 volt down here. So that's perfectly fine. So this code works just like before. So as I mentioned in the module related to the analog reference value, you don't, just because your sensor is running at 3.3 volts, you don't need to do anything special in your code. You could leave it uh, as as is. The only thing to keep in mind is that the Arduino does interpret 0 to 1023 in the range of 0 to 5. So when you're converting from a raw value to the voltage value, it does need to say 5 divided by 1023. However, sometimes we want to be a little more accurate, and depending on the type of sensors we use, we might want to let a full range of 0 to 1023 represent 0 to 3.3 volts. In order to do that, so right now the 0 to 1023 is basically mapped to 0 to 5 volts. Since our sensor is running at 3.3 volt, for sake of accuracy, and it might be important in certain sensors such as an accelerometer and so forth, the reading of the analog voltage is absolutely critical there. So we might want the full dynamic range of 0 to 1023 map on to 0 to 3.3 volts. In order to do that, we would use this particular function called the analog reference function. So here's the analog reference function description in from the Arduino website. So this basically allows you to choose any reference uh, based on the hardware that you actually have set up. So in our case, I have 3.3. In order to use the analog reference, one of the first things I need to do is also connect this pin right here. So this pin called AREF right here on the digital side of things, AREF, needs to be connected to the 3.3 volt pin. So let me make that red as well. So once that is connected, one of the things we want to do is before in the setup most of the time, we want to say analog reference or analog ref is the function. So so the function is called, where is my analog reference? Right here. So the analog function is called analog reference, and the parameter that it takes is either default, internal, or really external. So external, the voltage applied to the AREF pin is used as the reference. So now what this is saying is use the AREF pin for the 0 to 1023 map. Okay, that's what it's saying. So basically that means the 0 to 1023 now maps onto whatever is connected to this AREF pin. Currently 3.3 volts is connected to that AREF pin. So let's see what will happen if I run this simulation. So I have 3.28 volt here. And right here on my serial monitor, it's telling me that the voltage is 4.97. So something is not right. And if I look back at the code, what is not right is this particular statement right here. This statement maps the 1023 to 5 volt when we convert it from a raw reading to the voltage reading. But notice that the raw reading now is 1017, right? So 1017 before, if I look at my simulation from a little while ago before I did the reference, so let me comment this out and run the simulation, my reading were 671, right? If I enable analog reference external, what I'm saying is that my reading of 0 to 1023 actually maps into a voltage reading from 0 to AREF. In our case, the AREF is connected to 3.3. So we need to change that actual reading to 3.3 right here. And then if I hit start simulation, so notice before I hit start simulation, the raw reading is 671. The voltage reading is translated to 3.28. So by adding an analog reference external, I'm increasing my dynamic range to 1023. So 1017 now represents 3.28 volts. Okay, and I can change that right here, 1.45 to 1.11, right? So I can read all the way from 3.28 to 1.11 volts, and that's what I'm seeing right here. So analog reference, again, like I said, can be used for most of the sensors that we use, even if they are 3.3 volt sensors. We do not need to use the analog reference. But if we want a better dynamic range that maps 0 to 1023 to the full 0 to 3.3 volts, then this is useful. In that case, we would call analog reference external when we use it and put it in the setup, and the rest is basically the same. The only thing we have to be careful about is now when we convert the voltage reading, we are in fact converting the range of 0 to 1023 to whatever we've desired. In our case, it was 3.3 volts.